Assalamualaikum everyone. Today I will talk about Conceptual Modeling Approach 1 with Groundwater Modeling System software. So let's get started. At first, launch GMS. If GMS is already running, select the File New command to ensure that the program settings are restored to their default state. Then comes reading the image. To import the image, select the Open button and select the file start.gpr and open. Then comes saving the project. Select the file save as command. Select the file name and set it to East Text. Now comes defining the units. Select the edit button and units. For length, select meter, and for time, select day, and then select OK. Now comes defining the boundary. At first, we will create the coverage. In the Project Explorer, right-click on the empty space and then from the pop-up menu, select the new Conceptual Model command. For the name, enter East Texas. For type, select ModFlow and then press OK. Right-click on the East Texas Conceptual Model and select the new coverage command from the pop-up menu. Change the coverage name to boundary. Set the default elevation to 203 meter and then press OK. Now select Create Arc tool. Then we have to map the boundary. In case of drawing the boundary, we don't need to worry about the spacing or exact location of the point. Just use enough points to define the approximate location of the boundary. The boundary on the south and east sides of the model should coincide with the river. Now comes building the local source or sink coverage. Now we will right click on the boundary coverage and select duplicate command from the pop-up menu, and then it should be renamed as sources and sink. Then right click on sources and sinks coverage and select coverage setup. In the list of sources or sinks or BCs, turn on the following options which we will need for this tutorial. Check wells, refinement, specific head CHD, drain, and make sure the use of define model boundary option is on, and then click OK. Now comes defining the specified head arcs. Select vertices tool. Select the two vertices, one at this point and holding shift other at this point, and then right click on one of the selected vertices and select the node command. Then select the arc tool. Select the arcs on the south and east sides of the model by selecting one arc and holding shift key while selecting the other arc. Right click on one of the selected arcs and select attribute table command from the pop-up menu. In the all row, we will select specific head and then select OK. Click anywhere to unselect them. Then select the select points or nodes tool. Double click on the node on the west end of the arc on the southern bottom boundary. Enter a constant value of 212 for head stage. In a similar fashion, assign a value of 208 to the node at the junction of two rivers. And assign a value of 214 to the node at the top of the arc on the east boundary of the model. Now comes defining the drain arcs. Select the create arc tool. In our model we have 3 drains. So now we will draw down the drains. Next we will define the arcs as drains and assign the conductance and elevation to the arcs. So select arcs tool. Select all of the drains by clicking on the arcs while holding down shift key. Right click on one of the selected arcs and select attribute table command from the pop-up menu. In the all row type column, select drain option. Enter a conductance of 555 in the all row. Then select OK. The elevation of the drains are specified at the nodes of the arcs. The elevation is assumed to vary linearly along the arcs between the specified values. So now we will assign the elevations of the drains. For this node, we will assign the bottom elevation as 221. We won't change the head stage. For the second node, the bottom elevation will be 210. For this node, the bottom elevation will be 220. For this node, it will be 209. For this node, it will be 221. For this node, it will be 208. Now comes building the polygons. With the local sources or sink type coverage, the entire region to be modeled must be covered with non-overlapping polygons. So select the build polygon tool. Now comes creating the wells. There are two wells in our study area. One at the left and its X origin is 613250. And Y origin is 3428630. Now we will select the second well. For this, the X elevation is 615494 and Y elevation is 3428232. Now we will select the well and select properties button, and the type will be well, and flow rate for this well is -50. In a similar manner, we will change the properties of the second well and set it as well type, and the flow rate will be -300. Now comes grid refinement. For grid refinement, we will select the select points or nodes tool. We will select both the wells by clicking on the wells while holding the shift key. Then we will select the properties, and the refine column we will select toggle, and for base size we will give 25, bias will be 1.1, and the maximum size will be 150. Now comes delineating the recharge zones. At first we will copy the boundary. Right click on the boundary coverage and select duplicate command. Rename it as recharge. And then select the coverage setup. In the aerial properties, turn on the recharge rate property. Then select OK. Now comes defining the hydraulic conductivity. Right click on the boundary coverage and select duplicate command. Change the name of the new coverage as layer 1. Right click on the layer 1 coverage and select coverage setup command. In the aerial properties list, select horizontal K and select OK. Now we will assign the values of K value. Select layer 1 coverage and select the build polygon tool. Then select the select polygon tool and double click on the polygon and set a value for horizontal K as 5.5. Now comes defining the layer elevation. The final step is to define the layer elevations of the model. In this tutorial, we will set a constant elevation for the top and bottom of the grid. So at first we will copy the boundary. We will create a layer coverage by copying it. So right click the boundary coverage and select duplicate command from the pop-up menu. Change the name of the coverage as layer elevations. Then select build polygon tool. Now we will assign the elevations. Right click on the layer elevation coverage and select the coverage setup command. In the aerial properties list, turn on the following options. top elevation, bottom elevation, and then select OK. With the Select Polygon tool, double click on the polygon. Now set the top elevation as 230 and bottom elevation as 175. Then select OK. Now comes locating the grid frame. In the Project Explorer, right click on the empty space and then from the pop-up menu select the New Grid command. Now in the Project Explorer, right click on the grid frame and select Fit to Active Coverage command. Now comes creating the grid. Select the feature objects and map to 3D grid command. Right click on the grid item in the Project Explorer and select the new mod flow command. Now comes defining the active or inactive zones. Select the sources or scene coverage in the Project Explorer. Select the feature objects and active cells in the coverage. Then comes converting the conceptual model. Right click on the East Texas conceptual model and select it as map to modflow or modpath command. Make sure all applicable coverage option is selected and then select OK. Then comes checking the simulation. Select the modflow and check simulation command. Then select run check. As we can see, no errors were found. So select the done button to exit the model checker. Then select the save button. Now comes running modflow. Select the modflow run modflow command. Now if it is finished, then select the close button. Now comes viewing the water table in side view. Select the select cells tool. Now select a cell near the well on the right side of the model. Now select the side view button. Near the well, we can see as said that there is an interference of two cone of depression because of the two wells. So this was our GMS conceptual modeling approach 1. I hope you all liked it. Thank you.